Now we're going to draw a velocity time graph for this motion. This is uniform motion, so the velocity does not change with time. At time 0 seconds, the velocity is 20 meters per second. Time 1 second, 20 meters per second. 2 seconds, velocity 20 meters per second. 3 seconds, the velocity is still 20 meters per second. And 4 seconds and 5 seconds, still 20 meters per second. So we have a straight line with a zero gradient. Zero gradient means that it's flat. There's no slope. There's no gradient. Whenever we have uniform motion, we get a velocity time graph which is flat. It's a straight line with a zero gradient. What does the gradient of a velocity time graph mean? We know that gradient is rise over run. So the gradient of a velocity time graph is change in velocity divided by change in time. Change in velocity divided by how much time it took to make that change. In other words, the rate of change of velocity. The rate of change of velocity is acceleration. Let's look at this in units. The unit of rise, in this case, is velocity's unit, meters per second. The unit of run is time's unit, seconds. So the unit of the gradient is meters per second per second. In other words, meters per second squared. Meter dot second to the minus 2, which is acceleration's unit. So let's calculate the gradient of this graph. For the interval 0 to 4 seconds, gradient is rise over run, in this case delta v over delta t. Final velocity minus initial velocity over final time minus initial time. Now, it's actually a little silly to do this because it's so obvious that the gradient is 0. It's a flat graph. But let's go through the process anyway. So we take this interval here. The velocity at the end of this interval is 20 meters per second, and at the start it was also 20 meters per second. So the change in velocity is 20 minus 20 meters per second, 0 meters per second. The time at the end of the interval was 4 seconds, and at the beginning 0 seconds. So the change in time, the time interval for this interval, is 4 minus 0. 4 seconds. So no change in velocity was made during a 4-second interval. 0 divided by 4 is still 0. 0 meters per second squared is the gradient of this graph, and that's because the acceleration of this motion is 0 meters per second squared. Now let's calculate the gradient of the graph for the interval 2 seconds to 4 seconds. We can see anyway that of course the gradient is 0 because this line is flat. There is no slope. But let's do the process anyway. Gradient is rise over run. In this case, change in velocity divided by change in time. For this interval, the final and initial velocities are both 20 meters per second. Change in time is final time minus initial time. For this interval, the final time is 4 seconds, the initial time 2 seconds. Time duration equals 4 minus 2. The interval lasts 2 seconds long. 0 meters per second change in 2 seconds equals 0 meters per second squared. The gradient, of course, is flat. It's 0. And that's because the car is not accelerating. It's moving at uniform velocity. Now let's answer these same questions using the equations of motion rather than using the gradient of the graph. So we are asked what is the acceleration of the car during each of these intervals, 0 to 4 seconds and 2 to 4 seconds. Acceleration is change in velocity divided by the time taken. Velocity final minus velocity initial divided by t final minus t initial. For this interval, the velocity at the end is 20 meters per second, and at the beginning it was also 20 meters per second. The final time was 4 seconds, the initial time 0 seconds. 20 minus 20 is 0 meters per second change. 4 minus 0 is 4 seconds duration. 0 meters per second change in 4 seconds is 0 meters per second squared. The same answer as what we found before using the gradient. Acceleration for the interval 2 to 4 seconds. Acceleration equals change in velocity per time. V final minus V initial divided by T final minus T initial. Both the final and initial velocities are 20 meters per second because this is uniform motion, uniform velocity. Final time, 4 seconds. Initial time, time, 2 seconds. 20 minus 20 is 0 meters per second change. 4 minus 2 is 2 second interval. 0 divided by 2 is still 0. 0 meters per second squared. And we can see that these answers are all the same as the answers that we got when we used the graph. Because when we are using the gradient of the graph, we are calculating acceleration when we have a velocity time graph.